Good morning. So today we're going to go over the review sheet for graphing trigonometric functions. We'll start with number 1 here. It says to write the equation of a cosine function that has an amplitude of 3, period of pi over 3, horizontal shift of pi over 4 to the left, and a vertical shift of down 2. Alright, so basically we're going backwards here. Instead of being given an equation, and we find all of these things, we're given the pieces and we need to find the equation. So what we need to remember first is all of the kind of formulas that we have. So remember that our amplitude is the absolute value of A. Our period is 2 pi over B. Our intervals, although we won't need them for this problem, are the period divided by 4. Our baseline is D. Our start, which is the same thing as our phase shift or horizontal shift, is C over B. And our end, which again we won't need for this particular problem, is our start plus or minus the period. So those will help us throughout this review. All right, so essentially our standard form for a cosine is y equals A times the cosine of bx minus c, all plus d. So we need to find A, B, C, and D. All right, well, it tells us that our amplitude is 3. So if our amplitude is 3, right, that can just be equal to our A. Technically, you could also make your A negative 3 since the amplitude is the absolute value, but it really doesn't matter. All right, our period, which they tell us is pi over 3, and we know that that is equal to 2 pi over b. We can now cross multiply, and we get b times pi is equal to 6 pi, so obviously b is equal to 6. All right, next, our horizontal shift of pi over 4 to the left, that's the same as my start. Now we do have to be careful here that it's to the left. Right, to the left is the negative side. All right, so our horizontal shift is essentially negative pi over 4, and that is going to equal c over b. All right, we don't know c, but we did just find b here, so that's 6. Again, we can cross multiply here, and we're going to get 4c is equal to negative 6 pi. So of course we just divide both sides by 4, and we get that c, if we reduce this, is negative 3 pi over 2. All right, our vertical shift of down 2, that's the same as my baseline. Of course, down is the negative direction, so d is equal to negative 2. So now we have A, B, C, and D. All we have to do is plug them into our standard form for a cosine function here. And if we do that, we will have y is equal to 3 times the cosine of 6x. Now do be careful that our standard form has a negative here, and our c is also negative. So if you subtract a negative, it becomes a positive. So this will be plus 3 pi over 2, and then our d, all minus 2. So there is our cosine function. And next we'll go on to graphing sine and cosine. All right, again, we're going to be using all of these pieces up here. All right, so do be mindful here that my A is negative 3, my B is 4, and there are no C or D, so those are both 0. All right, so we know that our amplitude is going to be the absolute value of negative 3 which is just 3. Our period is 2 pi over b. Our b in this case is 4. So 2 pi over 4. You can reduce that, but sometimes you don't really want to. Eventually you're going to want to make sure that your start and your intervals all have common denominators, so you can hold off on simplifying to see how it works out. Our intervals, which again are the distance between our tick marks on our x-axis. Right, all we have to do is take our period, which is 2 pi over 4, and divide it by 4. That's the same thing as multiplying by 1/4. All right, so that's going to be 2 pi over 16, which is pi over 8. But again, we don't really know if we're going to need to reduce that yet or not. Now we can go on to the baseline. There is no d, so we said that was 0. So our baseline will just be the x-axis. Our start is c over b. We also don't have a c, so that's 0 over, or b is 4, 0 over anything is 0. And our end is our start, which is 0, plus or minus our period, which is 2 pi over 4. All right, so that's going to give us negative 2 pi over 4 to the left and positive 2 pi over 4 to the right. Okay, so now I'll go ahead and graph this thing. All right, so we want to put our start right in the middle. For this case, our start is actually our y-axis, which that doesn't always occur. Then we want to put 1, 2, 3, 4 tick marks to the right, and 1, 2, 3, 4 tick marks to the left. All right, remember our intervals here are the distance between each hash mark. All right. So, and like I said, you don't have to reduce any of this stuff. It doesn't really matter. So, since our intervals are 2 pi over 16, all right, that's the same thing as pi over 8. If you want to reduce, I'll do that for those of you who like to reduce. So here we would have 1 pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, and 4 pi over 8, which is pi over 2, which we did that correctly. These should match up, and if this is reduced, it does. Going the other direction, we subtract our intervals. So this would just be negative pi over 8, negative 2 pi over 8, negative 3 pi over 8, negative 4 pi over 8, which would be negative pi over 2. All right, so again, that should match up with this end, and if reduced, it does. All right, my baseline is 0, so that's just my x-axis here. You want to put some dashed lines here for guide, that's fine. I can't really tell on that, but all right, our amplitude is 3. That means we go up 3 from my baseline, and I go down 3 from my baseline. All right, this is sine. Sine always starts on the baseline, and my start is 0, so I will put a point here. Now, as we go to the right, we either go up first or we go down first, and that's determined by my A. If my A is positive, I go up first. If my A is negative, I go down first. So in this case, I'm going down first. So down, back to my baseline, up to my maximum, back to my baseline. All right, so if you want to connect these with a nice smooth curve first, all right, we can kind of see what our curve is going to be looking like. All right, so if we want to keep that pattern, we would have to go up here, back to my baseline here, down to my minimum here, and back to my baseline here. So again, connect these with a nice smooth curve, and there is our graph. y equals -3 sine of 4x. All right. I'm just going to do one more of these for time's sake. I'll go ahead and come down here and do part D, which has everything, right, as far as an A, B, C, and D. All right, so first we will look at the amplitude. Again, that is the absolute value of A. Well, actually, before we get started on this, do notice that this problem has kind of a number out in front of the parentheses, which we're not used to seeing. That's okay. Just go ahead and distribute this thing, all right? And they do have the D out front here, so do kind of notice that. So if we want this to look more like our regular standard form, right, we can say cosine. I'm going to distribute this 1/5. So this will be 1/5 x plus pi over 20. All right, and then we have plus 7 out here. All right, so now this looks more like A times cosine of bx minus c plus 7. Right? There is no A out here. Do be mindful that that will be 1 since it's something that's multiplying. So amplitude here will be the absolute value of 1, which is just 1. Our period is 2 pi divided by b, which is 1/5. Dividing by 1/5 is the same as multiplying by 5, so this equals 10 pi. Our intervals, we take our period that we just found, 10 pi, and divide it by 4. Again, that can be reduced, but you don't know if you really want to or not right away, so you can just leave it. Next, we go to our baseline. That's our D, that is 7. Our start, which is C over B. Do be careful here that our C, because there's a plus here, and in the standard form it's supposed to be a minus, so that tells me that my C is negative. So my C is negative pi over 20. And I divide that by B, which is 1/5. Again, dividing by 1/5 is the same as multiplying by 5. So this actually equals negative pi over 4. And then our end is our start, which is negative pi over 4, plus or minus our period, which is 10 pi. We will need a common denominator there, so that'll just be 40 pi over 4. All right, so that'll tell me that my left endpoint should be negative 41 pi over 4, and my right endpoint should be 39 pi over 4. I'll get this one when I subtracted, I'll get this one when I added. Okay, so again, we just want to start with an x-axis. All right, we always put our start right in the middle. So this is negative pi over 4. Again, I want 1, 2, 3, 4 tick marks to the right, and 1, 2, 3, 4 tick marks to the left. As I go to the right, I will be adding my intervals. So negative pi over 4 plus 10 pi over 4, this will be 9 pi over 4. Then 19 pi over 4, 29 pi over 4, and 39 pi over 4. If we do that correctly, it should match up here, and it does. All right, subtracting. Here we would have negative 11 pi over 4, but for space, I'm just going to do every other one. So this would be negative 21 pi over 4. This would be negative 31 pi over 4. And this would be negative 41 pi over 4. Again, if we did things correctly, these endpoints should match up, and they do. All right, now we want to notice here that 0 is not one of my intervals. Okay, so we need to think of two things when that happens. First of all, we need to think, okay, where is 0 going to be on this number line? 0 is always between a negative and a positive, right? Then you have to determine which one it's going to be closer to. In this case, it's going to be much closer to negative pi over 4 than it is 9 pi over 4. Think of that as negative 1 compared to positive 9. So my y-axis will be somewhere right in here. Right, the second thing we need to think about when 0 is not one of our intervals is that when we're going through and putting our points on our guidelines, right, there will not be a point on my y-axis. That's probably the most commonly made mistake. All right, so we know that our baseline here is 7. So I have to go up 1, 2, 3, 4, 5, 6, 7. All right, so here is my baseline. All right, our amplitude is just 1, so that means I go up 1 for my maximum, and I go down 1 for my minimum. All right, this is cosine. Remember, cosine either starts on the maximum or the minimum, depending on my a. If my a is positive, then we start at the maximum, which it is here. If my a were negative, we would start at the minimum. All right, so I go to my start, which is negative pi over 4, and I start at my maximum because my a was positive. When you start at the top, you only have one direction to go, down. So I go to my next interval, which is 9 pi over 4, go down to my baseline, my next interval, go down to my minimum, next interval, go back to my baseline, next interval, back up to my maximum. I can do the same thing going in the other direction. So I go to my next interval here, go to my baseline, next interval here, minimum, next interval, baseline, next interval, maximum. And I can connect all of these with a nice smooth curve. And we are done. All right, let's go to the next problem. All right, number 3, a little bit easier. It's actually kind of a mini part of what we just did. All right, here we don't have to do any graphing or anything, though. We simply need to find the amplitude and the period. So the amplitude is the absolute value of A, which in this case is 3. All right, the period is 2 pi divided by B, which in this case is 1/6. All right, dividing by 1/6, this is the same as multiplying by 12, so this is 12 pi. I do the same thing for part B. The amplitude again is the absolute value of A. All right, do be mindful that this is negative. The absolute value of it is positive. Do not put -2 there or you would be incorrect. All right, the period again is 2 pi divided by B, which in this case is 3 pi over 5. All right, now don't let dividing by a fraction confuse you. All right, dividing a fraction is just division. All right, so really this is the same thing as 2 pi divided by 3 pi over 5. If you remember from middle school, when you're dividing a fraction like this, you can keep, change, flip. So I keep 2 pi, I change my division to a multiplication, and I flip my fraction over here. Right, when I do that, this is over 1, I multiply across the top, multiply across the bottom. We get 10 pi over 3 pi, and the pi's will just cancel. So my period is just 10/3. All right, number 4 says, be able to identify the graphs of sine, cosine, tangent, cotangent, secant, and cosecant. Know the domain, range, x-intercepts, and any vertical asymptotes. All right, now there is a post under materials that just says other trig functions. All right, and it has all of this information for you. All right, I'm not really too concerned about sine and cosine, all right, because you're going to be actually graphing some of those by hand. All right, but this section on the quiz will comprise of 2 different parts. One part will just be a simple matching, where I will give you 4 graphs, one of which will be tangent, cotangent, secant, cosecant. All right, and then you'll have to match those with which graph is tangent, which graph is cotangent, etc. All right. The other section that this problem would cover on the quiz will just be a simple true-false. All right. It'll say, the domain of secant is blank. All right. And then you would just have to say whether that's true or false. Or the vertical asymptotes of cotangent are blank. All right. Now, you don't necessarily have to just stare at that sheet and memorize them. Right. If you actually combine what we know from rational functions that we studied earlier in the semester and some of the trigonometric identities that we talked about when we first got into trig, you can actually kind of just figure these things out. So, for example, cosecant of theta is equal to 1 over sine of theta. All right, so we know from rational functions that you get vertical asymptotes whenever the denominator is 0. Okay, well, where is the denominator? In this case, sine. Where is sine 0? Well, sine of theta is equal to 0, all right, at 0, pi, 2 pi, 3 pi, so on, forever. Also in the other direction, negative pi, negative 2 pi, negative 3 pi, so on and so forth, forever. All right, so that's where all of our vertical asymptotes would be. All right, so my vertical asymptotes are actually x is equal to 0 plus or minus k pi. Right, where k is just an integer, right? K is 1, 2, 3, 4. That's why we get positive 1, 2, 3, 4. Negative 1, 2, 3, 4. All right, so that's one way to think about it. All right. Also, our domain would just be all x's except these, right? Because vertical asymptotes are not in our domain. So my domain for this would be x not equal to 0 plus or minus k pi. All right. We can also similarly think of secant of theta as 1 over cosine of theta. So again, wherever my denominator is 0 is where I'm going to have vertical asymptotes. All right. Well, cosine of theta is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, etc. If you keep going around the unit circle. All right, and negative pi over 2, negative 3 pi over 2, etc. Okay, so my vertical asymptotes here are actually pi over 2 plus or minus k pi. Right, because every time you're adding pi, you're adding 2 pi over 2. So that's how we keep getting all of these, or subtracting it to get all of these. Right, again, of course, my domain, and this should be x equals these things, my domain is everything except that. Right, so these are easy way to kind of remember these without having to just stare at a sheet and memorize stuff. Right, now, similarly, all right, we can look at some of our other two trig functions. For example, tangent. One of our identities for tangent, our quotient identity, says that tangent is equal to sine of theta over cosine of theta. All right, well, since these two have the same denominator, they're going to have the same vertical asymptotes and domain. All right. Also remember from rational functions that to find x-intercepts, you set the top equal to 0. So since sine of theta is my numerator here, all of these would actually be my x-intercepts. Right? Cotangent works kind of similarly. So cotangent, of course, is just the reciprocal of tangent, which means it is cosine of theta over sine of theta. Well, again, here I have sine of theta as my denominator. So we're going to have the same vertical asymptotes and the same domain. Because of my numerator being cosine, wherever that is equal to 0, that's going to be where all of my x-intercepts are. So, of course, this would be where my x-intercepts are. So those are just kind of nice little tricks to remember all of that stuff. Knowing where the vertical asymptotes are are also great ways to kind of be able to determine between the graphs of tangent and cotangent and the graphs of secant and cosecant. All right. So do make sure that you look at that handout that's on Google Classroom under materials, but I also handed it out during class to everybody as well, so you should have a hard copy of that also. All right, and finally, all right, we have our calculator portion here that you don't really need a calculator on, so we don't need to worry about that. All right, it gives us a table of values. It says the normal monthly Fahrenheit temperatures for the last 30 years in Charleston, South Carolina are shown in the table below. Month 1 equals January, month 2 equals February, etc. All right. It says graph the function. I'm not going to have you graph the function, all right, but I am going to have you model the temperature T as a cosine function of time using 48 as the minimum value and 82 as the maximum value. Okay, now this is going to be a bonus question on the quiz. I guess we can't really see it there. All right, this is going to be a bonus question on the quiz, so I don't want you to stress out too much over this. All right, but again, it tells us to model it as a cosine function, so our standard form for cosine is y equals a cosine of bx minus c plus d. All right, now technically it said model the temperature T as a function of time, so we would want this to be capital T and we would want our x to be lowercase t. I'm not picky about that kind of stuff, so don't worry about that a whole lot. All right, but again, kind of just like in problem 1, we need to find A, B, C, and D. All right, well, how can we do that with all of this? All right, well, let's just kind of look at like a graph of a generic cosine function here. All right, so it would look something like this, and we would have our baseline in here like this, okay? Well, the first thing, we know that our A has to do with our amplitude, and our amplitude is the distance between the baseline and my minimum and between the baseline and my maximum, okay? So this would be like our max line, this would be our min line, okay? Well, basically, between my max and my min line, I have two A's, okay? So we can find the distance between these two lines simply by taking the maximum value minus the minimum value, all right? So A is going to equal the maximum minus the minimum, and then there's two A's in between there, so I divide it by 2, okay? So in this case, it says to use 82 as my maximum and 48 as my minimum. So this is going to equal 82 minus 48 divided by 2. All right. So 82 minus 48 is 34. Divided by 2 is 17. So A is 17. All right. Now we know that our period, all right, we have is 2 pi over b. Well, we're talking about months here, right? So if we're talking about a period is before things start to repeat themselves. Well, how long before months start to repeat themselves? 12 months, because there's 12 months in a year. So our period is 12 here. So now I multiply both sides by b, and we get 12b is equal to 2 pi. So I can divide both sides by 12 and simplify, and b is equal to pi over 6. All right, now next, our vertical shift, all right, or our start, is c over b. All right, now cosine, since we're dealing with cosine, that typically starts at the maximum. All right, so really we want to look at, well, what month does my maximum occur? All right, well, it occurs here in the 7th month, which is July. All right, so my start is actually going to equal 7 because cosine starts at the high point. All right, so here, using this, I have c over b, which I know b is just pi over 6, is equal to 7. All right, to solve for c, I can simply multiply both sides by pi over 6, and we get c is equal to 7 pi over 6. All right, so now we've got A, we've got B, and we've got C. All right, now all we need is D. All right, there's a few different ways that you can get D, right? D is just my baseline, right? And I already know what my A is, what my amplitude is, and we know what my maximum and minimum values are. So you could just say, okay, well, take my minimum value and add A, and that would get to my baseline. I could take my maximum value and subtract A, and that would get my baseline. Or you can think of your baseline, since we know that the baseline is right in the middle of the maximum and minimum, right in the middle is the average. So to find the average of something, you can just add them and divide by however many there are. Right? And I like to use this one. The other two are just as easy, but I like to use this one just because it's so close to A. So usually when I do these on my own, these would be the first two things I would find. I'll say, okay, well, I know A is max minus min divided by 2, and I know D is max plus min divided by 2. And those would be the first two that I would find typically. But in this case, we'll have 82 plus 48 divided by 2. All right, and that would be my D. All right, well, 82 plus 48 is 130. 130 divided by 2 is 65. Well, now I have my A, my B, my C, and my D. Of course, I can just plug that into my standard form for a cosine function. And we have y is equal to 17 times the cosine of pi over 6x minus 7 pi over 6, all plus 65. Okay, so just to kind of show you, all right, I graphed the data points that were given to me. All right, so this is month 1, 2, 3, 4, etc. And this is what it looks like as a scatter plot. All right, well, if I graph what we just found on top of that, all right, if we did a good job at modeling, it should cross a good deal of those points. All right, so if we type in what we just found, 17 times the cosine of pi over 6x minus 7 pi over 6 all plus 65. We go ahead and graph this thing. As we can see, it's a pretty good model. All right, so that's everything that will be covered on the quiz. For those of you at home today, B students, your quiz will be tomorrow. If you have any questions or concerns, please email me. I'll get back to you as soon as I can.